This is a presentation by Manitoba Public Insurance for Behind the Wheel training. The following presentation is about vehicle balance. An object in motion has to obey the laws of physics. When a vehicle moves or changes direction, the vehicle responds to certain dynamics, and these alter the balance. This module deals with vehicle dynamics, how they affect a vehicle's balance, and how the driver can use their vision to manage those dynamics to keep the vehicle in balance. Once you have completed this presentation, you should understand vehicle balance and its importance, understand and apply the concepts of pitch, roll, and yaw, understand what a transition peg is and what it's used for, know when to begin steering correction and acceleration using a transition peg, know the transition peg for a left and right turn, and finally, apply the concept of a transition peg when turning and steering. We know that an object at rest is in balance with the weight of the vehicle, which is distributed equally to all four tires. Movement causes the vehicle to become out of balance, and any change in steering, acceleration, or braking will affect the vehicle balance. The driver in most crashes has mismanaged vehicle balance by doing too much braking, steering, or acceleration, thus exceeding the capacity of the vehicle and its tires to hold to the road. Timely use of vision helps the driver determine what speed and steering choices will work to keep the vehicle in balance and thus on the road. As we said before, best balance is achieved when the vehicle is not moving. The cutaway tire patches show that the tire footprint is exactly the same for all four tires. Thus, weight is evenly distributed to all four tires. These are the four tire patches we saw from the previous slide. The vehicle dynamics change as the driver brakes, accelerates, and turns. As a result, the tire patches will change due to the weight transfer to different tires. Consider this. Your life depends on those four patches doing their job of keeping the vehicle in contact with the roadway. Changing vehicle balance will cause the tire patches to change size and affect their ability to hold the vehicle on the road. There are three terms we use when speaking of vehicle balance. Those terms are pitch, roll, and yaw. Pitch refers to weight transfer to the front or rear of the vehicle. Roll is when weight is transferred from one side of the vehicle to the other, and yaw involves rotation around the vertical axis. When a vehicle is sitting still, these do not come into play. When the vehicle is in motion, however, they play an integral part in what the vehicle does on the roadway. When you brake hard in a vehicle, the weight will transfer to the front tires. Sit up in your chair for a moment and imagine you are driving. What would your body do if you stepped hard on the brake? Intuitively, you know that your body would go forward toward the front of the vehicle. So what would happen to the tire patches? Well, the tire patches would become larger in the front than in the back, thus impacting your ability to maintain traction with the road. The opposite is true for a quick acceleration. This will cause the weight to transfer to the rear, making the tire patches larger in the rear and smaller in the front. If the acceleration is hard enough, the tires can actually become small enough to drastically affect steering. You've probably seen drag races where the wheels have actually come off the road. These are extreme cases, but the effect is that the driver loses all steering capacity. The laws of physics state that an object in motion continues in motion and in the same direction until an outside force acts upon it. In this case, the vehicle physically wants to continue, but the tires are redirecting the energy of the vehicle and turning it into the new direction. Vehicle weight is transferred to the side tires when turning or cornering because the vehicle's energy wants to continue ahead. The vehicle rolls opposite the new direction. With a hard right turn, the weight is transferred to the outside left tires, creating roll. The tire patch size increases on the left of the vehicle because the weight is transferred to that side with the redirection of the energy of the vehicle. It is the opposite for a hard left turn. If the force exceeds the tire's ability to hold the road, it results in a skid. If the tires grip the road too well and the speed is too great, the vehicle will roll over. If you could run a pole through the center of the passenger's compartment from the floor to the roof, this would be known as the yaw axis. A vehicle can spin around this yaw axis if during a curve both rear tires lose traction. At this point, the energy of the vehicle would cause it to spin on the yaw axis. In common terms, this is known as a spin-out. So what happens when you brake hard and steer to the right at the same time? You probably figured it out pretty quickly. The vehicle pitches forward and the weight is transferred from the back to the front. The vehicle also rolls because the weight is transferred to the left wheels. Finally, if the action is too great, the vehicle will yaw and the rear end will cause a skid. Now predict what the tire patches will do for each of the 4 tires. This diagram shows the tire pattern of the vehicle in the previous slide. Notice the left front tire. It has the most vehicle weight on it and thus has the largest tire patch. The right rear tire is the smallest. This has implications for traction, which could lead to a crash or spin out for the driver. This kind of hard braking and steering usually happens because the driver didn't notice the low speed needed for a curve or tried to do an evasive steering and braking maneuver at the same time. The only way drivers can avoid making such errors in the future is to use their vision to manage these vehicle dynamics and prevent these things before they happen. Keeping a vehicle in balance during a turn is a process of using your vision to time when and how you begin acceleration and steering recovery. There are 2 locations on the vehicle that help us know exactly when to do these 2 actions. These are called transition pegs because we begin to transition the energy of the vehicle going in one direction to a new direction, and we do so with precision to keep the vehicle in balance. Most people, when asked to begin accelerating and steering recovery during a turn, say, halfway through the curve. That's true, but most novice drivers don't know where that is. A transition peg is a tool to help all drivers know exactly when they are halfway through the curve. The transition peg for a right turn is the center of the inside rearview mirror. The transition peg for a left turn is the windshield corner post on the driver's side. Let's see how this works. From our previous presentation on reference points, notice that the curb lines up with the mirror, indicating that the bumper is in line with the curb. This is the place we begin the turn. The second is the target. We see the tree outside the passenger window. We are going to be heading towards the tree as we complete the turn. We keep our eyes on the target as we make the turn. Our vehicle turns, but our head and eyes remain on the target. Notice that the tree lines up with the center of the inside rearview mirror. You are at the transition peg for your right-hand turn. 2 things happen at this point. The first is you begin steering recovery. The second is light acceleration. While keeping your eye on the target, the vehicle will naturally go to the target and remain in balance. The question is now, have you completed your turn? The answer is no, because the target does not line up with the top of your steering wheel. Continue to turn until the 2 line up, and remember to see the target with your central vision and the steering wheel with your fringe vision. The vehicle is now on target, and you have completed your turn. Practice this skill in your own vehicle using targeting and transition pegs to help you develop the skill of keeping the vehicle in balance. Let's watch this video and see how the driver uses her transition pegs to begin steering correction and acceleration.
Straighten it now.
You have to tell me.
For a left-hand turn, look out the driver's side window and acquire your target. In this case, it is the tree at the end of the lot. Begin your turn when your vision no longer cuts across the curb to your target. Remember that the transition peg for a left turn is the driver's side corner post. The technical term for this is the A-pillar of the roof of the vehicle. Notice that the A-pillar is in line with the target. Now we are at the transition peg for our left turn. What two things should happen at this moment? Think about it. At this moment, you need to begin steering recovery and perform light acceleration. Is this vehicle on target or off target? Well, it turns out that the person steered a little too far past the target. It is off target because the top of the wheel is not in line with the target. Now ask yourself, where should you look and where should you steer to get the vehicle back on target? Remember, look to your target and steer to your target to get us back on track. Now thinking in terms of vehicle control, this vehicle is slightly off target. It's at the early stages of a rear wheel skid. If a driver fails to recognize this, they will continue around the yaw axis and spin out of control. But if the driver recognizes the movement of the vehicle is off target early enough, then they can keep the vehicle in balance and prevent the rear wheel skid. In this situation, which direction should they look and where should they turn in order to get the vehicle back on target? That's right. They should look to the target and steer right. This also works in skid recovery. In conclusion, using your vision helps you to figure out when to change speed and make timely steering inputs. It also helps you to know when to begin steering correction and acceleration during a curve or turn. And finally, it helps with early skid detection and recovery. After completing this module, you should understand vehicle balance and its importance. Understand and apply the concepts of pitch, roll, and yaw. Understand what a transition peg is and what it's used for. Know when to begin steering correction and acceleration using a transition peg. Know the transition peg for a left and right turn. And be able to apply the concept of a transition peg when turning and steering. Don't forget to answer the quiz questions on the Behind the Wheel quiz before you start the next module.